Welcome to a new video in my home automation Node-RED OpenHAB series. This time I will be looking at an example of how I would do an irrigation control, like the normal garden irrigation sprinkler system. And the idea is, or the assumption is, that I have a system where I have a pump and I have 3 zones, and I want to be able to set up the irrigation so it starts irrigating a particular time in the day, and then maybe not do it every single day, but only do it every second day or every third day. And also I want to be able to just shut the whole system off, because let's say I know that there are rainy days coming, so I don't want the system to waste water. And also I want some manual override, so if I want to just irrigate a single zone manually, then I can turn the zone on and turn the pump on to do that. Of course, the design is not limited to 3 zones. You can set up any number of zones. In terms of hardware, what I'm doing is I have a 5-volt relay board, and I started connecting pin 11, 13, 15 and 16 for the basically 3 zones and a pump, using the GPIO pins. And of course there are a lot more GPIO pins on the Raspberry Pi, so you can scale it up to any number of zones. What the code does in general is you have an enable. As you can see, I set the time to 1704 and it just kicked off. So it turned the pump on and the zone 1 on, and now it's already moved to the zone 2, and now it's going to move to zone 3, and at the same time it's counting up the uptime, how long the irrigation is running. And then when it turns off zone 3, it's going to turn off the pump as well. It's going to display a toast message saying that, okay, the irrigation is completed. So actually that's the whole function in a nutshell. And probably you could hear the relays firing in the background. So going back to the beginning, so that I have a main irrigation switch to turn the whole system on and off. And then you can set the start hour and time in hour and minutes using drop downs, and also you can say whether you want to do it in every day, every second day, every third day, every fourth day. It's based on my experience that I usually run the irrigation system every second day, so I just do like a bigger watering once and not to do smaller ones in every other day. I mean, that's just something that my gardener told me. And sometimes I also want to run the system like now, so I want to start it immediately, or let's say the next minute, and otherwise I just wanted to start it 9 a.m. in the morning, 4 a.m. in the morning, so in the closest time before the sun comes up in the summer. And again, you have the override switches. So if you want to add some or run the zone 1 for an extended period of time manually, you can just turn zone 1 and the pump on, and then let it running, and then we'll manually shut it down. What you see here in the screen is the actual irrigation logic, which looks quite a bit and probably quite complicated as well. But I'm going to break it down and start from the heart of the logic, from the middle. Before we dive into the actual nodes, I just want to say that for this one I'm only using the standard nodes, and I'm using the dashboard to render the UI. So the first node is the Inject node, and you can set up the Inject node in multiple ways. One of them is that it fires at a specific time, so let's say 4 a.m. on every single day of the week, and that will be fine if you are sure that you only want to start irrigation at 4 a.m. in the morning, because once you set this value, you can't change it from the UI. So what I have done instead is I am firing it every single second, and I'm checking whether the current date and the current time is the time where I want to start irrigation. But before moving on to that, if you would set it up to start at a specific time, then what you can do is you can use these trigger nodes to send out a one, which would be, you know, start a pump or stop a pump, and then wait for, let's say, 5 minutes or 10 minutes or 15 minutes, whatever the length of your zone is. And oops, sorry. So, and after that time, send out a 0, which would be, you know, turn off a zone or turn off a pump. And then what you would do is you would daisy chain these together. And also when you are daisy chaining it, you are sending the output also to the GPIO output, so it actually turns on and off the pump. And so you have a trigger, and after that you have a decision which says, is it if the value is 0, and if the value is 1, then it's basically not doing anything. So the trigger generates a 1 signal going out, and then this decision is not going to do anything with that. But once the time expired and it generates a 0, it lets that signal through, and then that goes into the message goes through this decision box, and then it goes to the next trigger, which again does the same thing. So it goes to 1, turns the zone on, and after the set amount of time it goes off, turns the zone off, and then the message goes through the second wait box and goes into the next trigger. So basically this is how I daisy chain the stuff together. I mean, the only reason I'm having 10 seconds in each of these steps because I just wanted to make it fast enough for demonstration purposes. So that would be the basic logic. So one complication is that I wanted to make sure that I can set the time when this whole irrigation starts. So let's look at that time logic. It's not the time logic, it's everything behind these two ties or these two groups on the UI. So first of all, I wanted to have these preset times, so I don't need to, you know, scroll through all the options here, because I want that if I want to start irrigation now, I just click on this button. If I want to set it back to the, you know, the normal morning running, I just click on the other button. So I have these two buttons, and they don't really do anything. They just there for the UI stuff. So when I click on them, they send off a message to these two. So there are two boxes for each one of them to set the time and the minute. So all I'm doing here is setting. So let's say the zone is easier one. So what I'm using here is I'm using the change node, which basically sets the payload to 4, which is the 4 hours, and then sets the payload to 0, which is the 0 minutes, and then I'm feeding that into the drop downs. So as a matter of fact, I'm changing the values of these drop downs by pressing on the button. And if I do the same for the now, then I just add another piece of code which gets the current date and time, the current timestamp, and then I'm extracting the hours. And for the minute, I'm doing exactly the same. I'm extracting the minutes, and I'm adding 1 minute to that. I'm getting the current time. I'm extracting the time part of it. I am adding 1 minute to it, and from the final date, I'm just getting the minutes. And actually, I just realized that if I push this button at something hour 49, then it will reset to the same hour 0 minute, which is going to be only executed next day. So there is a little bit of issue with this logic. So again, as I said, the 2 hour boxes go to the hours, and the 2 minute boxes go to the minute. And all I'm doing here is defining the drop down. So I define all the hours, hour options, and I'm defining all the minute options. And I'm also setting the topic to time minute and time hour. And in this function, what I'm doing is saving the values in the global variable, so with the topic and the value, and then I'm getting the two to both the hour and the minute. I'm checking that none of them are empty. So let's say when the system starts up and there is no hour or minute calculated. So when I have an hour and a minute, I basically construct a date type, like a date variable, setting the hour and the minute and the second to zeros and the millisecond to zeros and the year to like a standard date. And then I'm storing that as the start time in the system. And in the payload, I'm just sending hour colon minute, and which goes into a text node where it is getting displayed. So it's here. It's not nicely formatted because it's missing the second zero. So that's about setting the time. And the next one is this enable slide and these two elements at the bottom. So the enable is really simple. I have a switch which either puts out 1 or 0 with the topic enable. All I'm doing in the next box is I'm saving this in the global variable, and pretty much the same for the irrigation days. So I have values which is every day, every second day, every third day, every fourth day. So 1, 2, 3, 4, and I'm sending it with the topic irrigation days, which again I'm storing in a global variable. And I have a piece of logic which says that if the irrigation is enabled, then I'm working out whether I'm going to irrigate today, which is today. So I'm getting today's date and I'm dividing it by either 1, 2, or 3, and based on the output, whether it's like divisible by 1, 2, or 3, or 4, I calculate whether I need to, run irrigation today. And also I'm sending the result out to a template node, which formats the output. So it either says yes or no, and it displays it in either green for yes and no for red. So that is responsible for displaying this last line. Going back to the main logic now, all the system checking is basically executed by this inject node, which is firing every single second. And in every single second, I do a couple of things. So first of all, I generate the current date, and I'm removing the date part of it and the millisecond part of it, so that it gets comparable with the start time. And I'm also copy and pasted this logic from an earlier piece of code which does the whole thing, like it checks whether the enable is set to 1, and it calculates whether the today is the day when it needs to run the irrigation, and it's based off the same logic. So I divide the current date by this 1, 2, 3, 4, which is coming from the drop down, and if it's true, I'm returning the current date, which then later gets compared. Otherwise, I'm sending 0, which means that it's the next step when I'm comparing it with the date never gets true. And then here it's a really simple, it's the standard switch node, which says if the payload, which is the formatted date, well, actually the formatted time, equals to the start, which is the start time that we have saved in the global variable, is the same, then we start the whole process, and then it goes into the triggers, which I have explained earlier. A few other things I'm doing here is this notification. That displays that toast message notification, which came up on the upper right corner of the UI. And all I'm doing is, well, that basically displays the topic and the payload. So there is no settings in here. It just displays the topic and the payload. So I have this change node where I'm setting the topic to irrigation and the payload to irrigation has started. So this controls what gets displayed on the screen. Also, what I'm doing here is sorry, I will come back to this later. So if the time is right, so I need to start the irrigation, the message will flow here. What I'm changing here, I'm changing the message payload to 1, because and I'm sending this payload to this link. So as you can see, there are a lot of links here, and I'm using these links to make the flow a little bit neater, because otherwise there will be a lot of lines going back and forth. So I moved all the UI update to the separate part of the screen. So here I have a destination to this link, which basically does goes into a template node, which updates the screen whether this output is on or off, which we see here. So it's on off, and also it then I have a piece of function which swaps the message payload around. So if it reads 1, then it's sending out a 0, and if it's otherwise, it's sending out a 1, because the relay board I'm using is active low. So in the program logic, I'm saying that 1 is on, but actually I need to send the opposite value to the output, and I'm using the GPIO output. So this is where I have configured that I'm using pin 11 for the first output, which is going to be the pump, and I'm setting that initially set the pin to high, because that means that the relay is going to be off. And by the way, if you see, all of the other links basically do the same with the output. So it displays the UI element, and then it flips the output to active low, and then it sends it out to the GPIO output. And the last one, which is like this one, is all about updating the time in the bottom of the screen. So it's this uptime thingy, and there is a bit of code which calculates the time, because the way I store the information, like how many seconds has elapsed since I started the process, is stored in milliseconds. So I'm dividing it by 1000, and then I'm formatting, if it's seconds, then just seconds, and if it's minutes, then I do 1 minute 5 seconds, something like that. Going back to the main logic, when the current time equals to the start time, then I start the pump, and I also go to this one which starts the counter. So I just have a couple of global variables again to store what is the actual pump state, what was the start time, and this is the time when it started, and that's the run time. And I'm using a second variable because I'm updating this start time all the time. And the actual update, which again executes every second, is actually here in this function box, which again gets triggered every single second, because this inject executes every second. And I'm just doing the normal logic. If the pump is running, then I'm calculating the how much time has elapsed from start. I'm putting the actual value into this global variable, and I'm pushing the same stuff out to the payload. And then every time I update something about the runtime, I'm calling this link. So here, here, and here, and I'm just updating the time on the screen. So pretty simple. And at the end of the last trigger, when it changes to which it goes to 1, and then finally it changes to 0, then again I wait for the final 0, and I push that out back onto the pump, just to make sure that once all the zones are completed, I turn the pump off, and I display the toast message saying that the irrigation has completed, and I stop the counter, and I calculate the final pump time and update it on the screen by calling the link. So that would be the main logic, and what's left of it is this last piece, which is responsible for this manual override. And again, it's really simple. These are like UI switches which either send out a 1 and a 0. Yeah, we can argue why I'm sending the 1s and the 0s out as strings. I should send them out either as booleans or number values, but I mean, this is how I started designing the code, and I just keep it that way. So this switch either sends out a 1 or a 0, and I just send it to the corresponding link destination, where the screen gets updated, the value gets flipped, and it's sent out to the GPIO output. So if I click this, then the pump turns off, and zone 1 turns off, and zone 2 turns off, and zone 3. And you can do the same all the way back, and probably you can hear in the background and the relay is firing all the time. So that would be about the my take on the irrigation stuff. You can probably say that there could be a lot to improve here. Mostly is somehow take weather information into account, but I yet to find a weather service which is good enough to tell me what's the chance of precipitation and what's the amount of precipitation which is expected for the day, because I think based on that information you can make an informed decisions. Otherwise it will be pretty much just guesswork. And also I haven't found any service where I could say how much rain I had today or the previous day, which again would tell me that if I had a big rain, probably I won't need to irrigate for an entire week or something like that. So, and this is why I included the enable switch. So if the rain comes, you come to the UI and turn it off. So that will be all for now. Again, if you like the code, you find the link in the video description, and see you in the next episode.